Alright, so looking now at Chapter 6, so this is the Section A worksheet problem, so we're doing all but those listed here. So I'm going to start off with number 1 and just go on down the list. Pretty heavy dose of just formula use with most of these problems, so a lot of this is just going to refer to the formula packet and make sure we pick the right formula and then solve correctly from there. So first one, we got sum of an arithmetic series. So do keep in mind, typically when you're dealing with a sum, they refer to a sequence as a series whenever you're doing a sum. So otherwise, if we're just identifying specifics within a sequence, we just call it a sequence. So anyway, this one is telling us it has an n number of terms, so we don't know how many terms, but we know the sum is 840. We're given the first term and the common difference, and so we are solving this one for n. So again, first things first, it's got to pick a right formula. This one's talking about the sum of an arithmetic series. So looking at our formulas for this one, there are two formulas we could use. There's sort of a longer one here, and then we have the shorter one here. The longer one always works. The shorter one sometimes works. It just depends on the information that you're given. So for example, on the shorter one, U1 would represent the first term. This would be the value of that term. So let's just say it were 20 terms, so n would be 20. This would be the value of the 20th term. In the problem we're doing right now, we don't know that information, so we're going to stick with this formula. This is the one I would get comfortable with anyway because it always works. So this one kind of has some limited use to it, so we'll tend to go with the longer one. So let me write that one down here real quick, and then we'll start putting it to use. So we're just doing the sum of our arithmetic on this one. So 2 times the first term, which was given to us, plus n minus 1d. Okay. So there's the formula we're using for this one. We'll just start summing in the info. We know the sum was 840. And we don't know the number of terms. So we know our first term was 80, so 2 times 80 for that first guy. And then right here, I'm just going to distribute the common difference of -4. So -4n plus 4. To start doing some cleanup along the way. So inside, we're going to combine like terms and get 164. I got a couple options you could do from here. I'm going to multiply 2 over to the left. I think that's just going to be a little easier to work with. So 2 times 840 would give me 1680. And then we got that n right there, which we'll distribute in a minute. So I'm looking at the 164 minus 4n. And now I can distribute that n. You're going to see that's going to cause an n squared. So I know I'm going to be solving a quadratic. And we know we like our quadratics to equal 0, so I'm going to also subtract my 1680 over while I'm doing all this. So distribute the n. So I'm going to be looking at a negative 4n squared plus 164n minus 1680. So a couple things we can do from here. We're just solving a quadratic, so now it's just kind of about making life easy for yourself as you're solving this. We can use quadratic formula, factoring, whatever makes sense to you. In this case, just to make life easier for myself, I would divide out everything by -4 just to simplify the terms. I don't like my leading term to be negative anyway, so I would have at least divided everything by -1 to change all my signs. But in this case, we're going to divide everything by -4. So we're going to be looking at n squared for the first term. Then I got a negative 41n for my middle term, and then a plus 420 for my third term. So, from here, it's just a matter of what method you want to try to use to solve. You can try quadratic formula, you can try factoring, whatever works best for you. In this case, it looks like our two factors are going to be 20 and 21. So just looking for those two numbers that multiply to be positive 420 that would add to be negative 41. So n minus 20 and n minus 21. We'll do that for us. So that means n equals 20 and 21. In this case, we do have two possible solutions. Both of those are acceptable. The cases that wouldn't be accepted typically would be like a negative, because you can't have a negative number of terms. So since we're solving for a number of terms, our answers are going to have to be positive on this. So if I did have a negative, I would reject it. Since both of these are positive and they do fit, if you plug them back in, we will accept both answers. Moving on to number 2, so we got the sum of the first n terms of an arithmetic progression, so just an arithmetic sequence. And they're giving us a sum function for s of n, so anytime you see that s of n, we know it's a sum. Find the common difference. So keep in mind, if I were to start plugging in some numbers, right, n represents the term number, so if I were to plug in a 1 for n, so 2 times 1 squared plus 9 times 1 would give us 11. So that tells me the sum of the first term is 11. Well, keep in mind, if I'm adding terms, if the sum of the first term is 11, that means the first term is 11. So we can also safely say that the first term is 11. So by the way, sometimes we put a of 1, sometimes you put u of 1. Doesn't really matter, it means the same thing. So first term is 11 because simply the sum of the first term is 11. There's only one term there, so both of those would have to be the same thing. So if we wanted to find the sum of the first two terms, so I would plug in a 2. So sum of the first two terms, so 2 squared times 2, and 9 times 2. So if we add those up, we're looking at 26. So keep something in mind here. I know that the first term is 11. So if I was just starting to build the sequence, I know the first term is 11. The second term we don't know yet. All right, so the sequence is looking something like that. All I do know is that the sum of the first two terms is 26. So 11 plus something is going to add up to 26. So in this case, if we just kind of build a basic equation, 11 plus whatever the second term is going to give me a sum of 26. So that tells me that the second term would have to be 15 in order for that to make sense. So we can see right here that if my first two terms are 11 and 15, their sum is 26. So that would make sense for that equation. So here's something we got to keep in mind. We now know that the first term is 11. I know the second term is 15. So when they say what is the common difference, well, you can see to go from the first term to the second term, we just added 4. So I know the difference between those two terms is 4. So there's our common difference. So moving on to number 3, we got the sum of the first two terms of a geometric progression is 16. And the product of the first three terms is 1728. So what is the fourth term? So in this case, the sum of the first two terms is 16. So for the first term, we'll just call that A1 or A. So we don't know what that term is. We're just going to use that to represent the first term. The second term, so keep in mind with the geometric pattern, you're always multiplying by something to get the second term. We just call it the common ratio is what's being multiplied. So we'll just use an R for that. So if this is my first term, then if I were to do the first term times the common ratio, that would give me my second term. In this case, all we know is that the sum of those two terms is 16. So that's all the information we're given to start with on that. We know the product of the first three is 1728. So we're going to use a similar idea and do a product and set that equal to 1728. So I know I have the first term times the second term times the third term. So keep in mind, if I were to multiply the first term times the common ratio, I get the second term. If I multiply by the common ratio again, I get the third term. So, So for this case, I'm doing the second term times the common ratio to get the third term. So now I have another common ratio involved to get that third term. it says their product was 1728. So there's another equation that we can now set up. So let's just do a little combining right here. I have a times a times a, which is a to the third. I have r times r squared, which is r to the third. So since that's a perfect cube, I can cube root both sides to clean things up a little bit. So now a times r is the cube root of 1728, which is 12. So we now technically have the second term in our sequence. We now know a times r is 12, and that was representing the second term of the sequence. So the first term plus 12 should give me 16. So we can just do a little basic subtraction on that to figure out that our first term is 4. So we're just plugging that 12 back in right here, and then subtract that over, and we got our first term is 4. So we can now say that a sub 1 is 4. Our second term was 12. And a little back substitution here. I can now put my 4 in right there, divide that over to figure out that my common ratio is 3. So think of the sequence that we got going on here. I know my first term was 4, and I am multiplying by 3 every time to get the next term. So if I did 4 times 3, I get the second term, which we already knew, times 3 gives me the third term, times 3 again will give me the fourth term, which is 108. I just kind of did that by hand because it's only the fourth term. If they were asking me for something much farther down the line, like let's just say the 20th term or something like that, then I would have tapped into a formula to get that answer. But this was so short and simple, there was just kind of made sense to just kind of keep the pattern going and do it by hand. So number 5, arithmetic series. Again, remember it says the series, so they're describing a sum when they use the word series. At least they should be. The first term is -9, and we know that sum of the first 16 terms is this. So let's just start with that. So arithmetic series, remember just figure out the formula first. So we've already looked at that one a little earlier on, so let me just throw that one out here again really quick. So 2 times the first term plus n minus 1d. So let's just start plugging in a few things. We know the sum is 336. We know that there are 16 terms, so 16 divided by 2. We know the first term is -9, so 2 times -9. Again, we knew that the n was 16, so 16 minus 1 is going to give me 15d. And we know everything in that equation except d, so we can just solve for d on that. Alright, so just keep on solving that one all the way through. Should come out with a common difference of 4. Looks like, if we're doing that one right. So now they want us to find the 7th term. So just go back into the other arithmetic formula for finding a specific term, which is our u of n formula, which is just first term plus n minus 1d. So we can now just plug into that. So we know the common difference is 4, so we can sub that one in here. We are looking for the 7th term, so we're going to put a 7 right there. We know the first term was -9, so we're going to put a -9 right there. And if you just clean that up, you should come out with the 7th term. So putting that one there, 7 minus 1 times the common difference. So a little cleanup on that should get you the 7th term. So number 6, geometric sequence. We got the 2nd and 5th terms, trying to figure out common ratio and the sum of the first 6. There's 2 approaches to this. One is to work with this as the 2nd term, and this is the 5th term. You just plug those into the u of n formulas. You create a system of equations, and then you just solve the system by using substitution. One little shortcut you can kind of take advantage on this is to do kind of a little slide. I know that's the 2nd and 5th terms, but if we just treat this as kind of bumping everything down one, think of this as the first term and the 4th term. that would help us solve for r quicker. So it's just a little easier than using the first method I described with that system of equations. So let's just kind of treat this as the fourth and first terms and do that little shift. I think that'll make things a little easier for us. So we're using our u of n formula for geometrics. So u1 times r to the n minus 1. So again, we're going to treat this as the fourth term. So we got the 243 over 2500. And we're going to treat that as our first term. So times r to the 4 minus 1, since we were treating that as our fourth term. And notice we can now just solve this for r. So you're going to multiply by the reciprocal of this over to here. And then since this is r to the third, just cube root both sides to get your common ratio. So if you did solve that through, we come out with a common ratio of 3/5. And that was just a much quicker way to go. So now if we want the sum of the first 6 terms, so do keep in mind, we want to find the real first 6 terms. So we knew this was the second term, and we knew the common ratio, so keep something in mind here. If I were to do the first term times the common ratio, that would give me the second term, which is this. So we're going to use that simple little equation to figure out what the real first term was. So if I multiply by the reciprocal of that over to the other side, we can get our first term, which is what we need in order to do this last part of the problem. So multiplying by 5/3 over to the other side will help us get there nice and quick. So looks like 3/4 for our first term. So now we can use our geometric sum formula to get the sum of the first 6 terms, which is one we haven't looked at yet, so let me pull that one up real quick. So right here we have 2 ways that you could write it for a geometric sum. I strongly encourage the first way. People have an issue with calculator stuff when you have the negative here and then you have something to a power. So I would advise you to go with this route. It's the exact same formulas. I just think this one goes in easier into a calculator, so that's the one that I would use. So for that one, we have our first term. Oops, there we go. So we got our first term, which was 3/4. We got our r to the n, so 3/5 to the n. And we're finding the sum of the first 6 terms, so we're doing that to the 6th. Minus 1 over r minus 1. So from there, just using a little calculator work to get that one. Anytime you're dealing with negatives or fractions or anything like that, I always encourage you to use parentheses. Otherwise, do it in pieces just to be safe. But if you wanted to do the whole thing in one shot in your calculator, play it safe and use some parentheses right there and right there. Then you could do the whole thing in one shot, and you're a little safer to make sure you get the right answer if you do it that way. So make sure you're using parentheses the correct way to get the right answer. All right, moving on to number 7. All right, so for number 7, we got the nth term of a series. Now a series is a sum, but they're specifically telling us right here that this represents the nth term, not the sum. So in this case, this is just like a u of n type of an expression right there. So it just represents an nth term, not a sum. But we're going to get to that part here in a second for the sum. So first just want to figure out some of the terms in the sequence. So if we plugged in a 1, 25 minus 4 tells me my first term. If I plug in a 2, so 25 minus 8 tells me my second term. And if I plug in a 3, 25 minus 12 tells me my third term. So you can see right there that we are decreasing by 4 every time, which means this is an arithmetic pattern, and the common difference is -4. So a couple things that we can figure out right there just by plugging in a few numbers to get that information. Since it's arithmetic, we're going to use for the next part the arithmetic sum formula that we've seen now a couple times. So we know the sum of arithmetics looks like this. So we're just going to plug in what we can at this point, leaving n as n. So we know we're not going to plug this part in just yet because we first just want the expression. So for this part, I'm just going to leave this as s of n for now. Do a little substitution and clean up for whatever we can. So replacing the first term with 21, we're leaving n as n for now. So 2 times 21, so we're looking at 42. We know the common difference was -4. So let's just clean up as much as we can on that. So right here, -4n. I'm going to have +4 plus 42. So 46 on that. Now I can distribute my n over 2. So right here I'm going to be looking at -2n squared. And then right here I'm going to see 23n. So we now just accomplished this goal right here. Oops. Sorry, I didn't realize I was sliding off camera. So we just accomplished this goal right here by doing that process that we just saw. I flipped the order on that, so I would reverse that so that I could make it look like this. And that way I could see that the a value is 23 and that the b value is -2. So we developed the expression. Now we could find the value for n, for which the sum is -285. So we're just plugging that one in right there. And then similar to what we did earlier in the video, we are just solving a quadratic. So I would get all my terms onto one side. I would make sure that my leading term is positive. So maybe just move these two terms over to the left, and then you are solving that quadratic. So you always got the options of quadratic formula or factoring. There are some calculator ways of figuring out that stuff as well. So if you're interested in that, you can come on in and I can show you how to use your calculator to solve quadratics also. Do keep in mind that for this one, when solving a quadratic and you typically get 2 solutions, keep in mind n represents a number of terms and you can't have a negative number of terms. So in this case, if you do get a negative, you can eliminate that option and just keep the positive.